Hi, in the last experiment we have displayed some message onto cross-section LCD. In this experiment we are going to get some data in real time from external switch and update on LCD. So that will be helpful when we are going for implementing 4x4 multiplier on LCD. Let's quickly create a project. I name it as binary to LCD. Select the board Spartan 7. Finish. First, what we can do is we can add that existing LCD code and modify them to support that inputs. In the previous code we have created, so here is the code that we have created previously. So this simply display some characters, that is hexadecimal value on LCDs. But what we want to do is we want to provide some input to this LCD code. To do that, I simply again copy this code to that new project, copying it to new project folder, pasted that VHDL file in the directory, and finish. So we are going to modify this LCD code so it can accept that inputs. First we get the binary input, convert it to BCD, and then when displaying it on LCD we convert that BCD into ASCII format and display. So for this LCD we first take that input as a BCD here. So this BCD of 3 data we are going to display. BCD of X, which is of input standard logic vector of 11 down to 0. Similarly, we have it 3 times and make it as Y and P. We do have that multiplier input X and multiplier input Y and product output P. So for that we have it as a 3 inputs. So we can straight away use the same thing for our next example. Next we have to modify that data row. It will be like on first row of LCD we are going to display X input and get the X input from slide switch and display it over that X hyphen then X value, then add some space, and after that we again display Y hyphen, then we get the 3 inputs from, we get the binary input from another slide switch and display it over that next 3 position. After that we move on to next second row P hyphen, then get the output and display it. So this is how we have to rearrange this data row. So first we have that 5 control signals. After that we have to provide that whatever the ASCII for X. So C0 is the second row. Initially we are going to type it on first row, 80. 80 starts with the first row, first position. If you want to shift the 2 positions next, then we can type something like 82. So it starts from first row, third position, like that. So it starts there. Then we have that ASCII table So that will help us to identify that whatever the ASCII value corresponding hexadecimal number. For X it is 58, capital X. So I name it as 58 here. Then after that we can provide some hyphen. For hyphen it is 2D. Then we have to enter the three values. I simply assign all three values with 0, that is 30. For 0 we know that value is 30 hexadecimal. So I give something like 3030, that is simply assigning 0 initially. Then after that I provide some space, like for space we have ASCII value of 20 for space. So I simply enter 20 3 times. Then after that we can enter that XY value, that is Y value is nothing but 59. Then again hyphen 2D. Then we need to assign 3 zeros which will be replaced with that Y value, 3 zeros. Okay, we have all the informations of first row. Then we have to move on to second row. For that, this 82 is for first row. Then for second row we have C0, right? C0 starts from 0th position, but we want to center that output value, so I make it as something like C5. Second row, 5th position. Okay, next we have to type that P value, that is P50. Then for a hyphen we have that 2D. Then we have 3 values, right? I simply copy these 3 values and enter here. Okay, fine. If you count on this, there will be 24 values. So assign 24 here. Data position should be greater than this one, because we have the counter that is incrementing every time. So we keep it as 25. 1 to 25. So next what we have to do is, instead of simply outputting all the values, we have to provide the condition that up to certain value, that is if the data position less than or equal to 7, then it should display this one, data. Else, if that data position reaches that 8, then you can see that up to data 7, that is up to 5 is control signals, and then 6 and 7 are that X hyphen. After that 3 dummy values, right? This is the 8, 9 and 10. This would be replaced with that BCD data, that is X value, that we have to assign. Here we have to assign data equals BCD X value of that 11 down to 8. See, we are not going to display that directly BCD value to LCD. We have to convert them to ASCII. For conversion, let's say if anything like 1 to 9, if we want to display it in ASCII, that for 1 it is 31, for 9 39. So we have to add 30 with this value, then it will give us that 39 or something. So what we can do is we can put something like hexadecimal value of 30 plus this. So this is throwing error because we have to assign the library unsigned. Okay, fine. Next. Similarly, for all those positions like 9, 10, everything we have to, for 3 positions, we have to assign that exact value. If it reaches 9, it should be with that 7 down to 4. Then if it reaches 10, the data out should be of 3 down to 0. Okay. Next, once it reaches that 11th position, that is 11 to 15th, you can check here, that is 11, 12, 13, 14, 15. Again that y hyphen. So these 20 are for space between x and y values. So we have to again I copy this condition and paste it, and less than, it should not be like this, greater than or equal to 11, and again data position less than or equal to 15. Then we have to assign this data value, it is of else if. Okay. Next, we have to assign that next condition 16, 17, 18, that next 3 values, that I simply copy that existing part and paste it here and name it as 16, 17. This is for y values 18. Then make it as y, BCD y will be assigned to these locations. Okay, fine. Next we have another condition, that is reaching the second row. Again I copy all this thing and this should be like this is from 19 to 21 actually. So 19 will be this position, that is C5, 20, 21. After that we have again the 3 values of P. So just rename it as 22, 23 and 24. BCD of P. Okay, fine, P. Yes. So next we have to end this if statement. So after that we have everything as usual, but in case of this data position, right, so this logic, this is for identifying that register select where it should be 0 and where it should be 1. But in our logic we have that control signal coming at 2 position, that is this position, and when it is of 19, when data position is 19, again this will be set as 0. Else if condition, else if data position greater than or equal to 6 and data position less than or equal to 18. Then I provide that LCD register with 1. Once it reaches that 18th position, we have to make it as 0 again. Else if data position equals 19th position, then we have to set the LCD registers with 0. That is the control line for second row, control signal for second row. Then again, if it is greater than that, greater than or equal to 20 and data position less than or equal to 24, that is the last position, then we have to make that register again 0. So this is the logic. So we have that first control, then data, again control here, again data here. Okay, fine. So once the data position reaches, it should be greater than, if data position reaches 25, we set it to 5. So we have that LCD modified. Then next thing we have to do is, we have to add that binary to BCD conversion code. So that only can convert that input slide switch to BCD format. So we have to add that binary to BCD code as well, and binary to BCD, finish. Okay, we have that binary input to BCD conversion code. Now we create one new top source, combine these LCD and binary code into one. Create. So I name it as binary to LCD. Finish. Here what are all the inputs required here? Clock will be an input, then X will be the input, Y will be an input, then P also we are providing as an input in this code, but on multiplier P will be an output. So here we are also providing P in as an input through slide switch. Then we have that LCD RS as an output. Then LCD enable also as an output, and data of 8 bits, 7 down to 0, right? Okay. So that X, Y and all we make it as 3 bits of inputs, 3 down to 0, that is 4 bits of input, and P we keep it as 7 down to 0. That for X we use the first 4 switches, then Y next 4, and for P next 8 switches will be assigned. Okay. So we have that code added. Now we have to port map all the parts, that is both LCD and binary to BCD. I copy that binary to BCD entity, and also copy that LCD part, and rename it as a component. Okay, so we have renamed it. Next will be we need signal that signal is of that BCD X comma BCD Y, then BCD P. That I name it as standard logic vector of 11 down to 0, because this BCD is of 4 bits each, so 11 down to 0. Next we have the port mapping part. So first that we port map that binary BCD. I name it as binary BCD part 1 and copy that name. Port map. Then we have what are all the inputs outputs for clock. This I'm assigning as that formal port with that actual port. So clock, then we have that binary. For X input we are going to provide only 4 inputs. So what I am going to do is I simply assign 7 down to 4 with all zeros. With 4 zeros and that binary of 3 down to 0 with X. 0 with the value of X. Then output will be that we are going to assign this BCD 0, 1, 2, 2 that BCD of X. Okay, first assign BCD of 0, which will be assigned to that BCD of X 3 down to 0. 0. Then again repeat this for 3 outputs. So BCD of 1, BCD of 2, then this will be of 7 down to 4, then 11 down to 8. It's close this one. Okay. Next we simply copy it 3 times because we have that X, Y and P inputs. So paste it. Then I name it as 2 and 3. Here the only difference is here X is coming, here it will be Y. Then one more thing, it's a small x. Even though it is not case sensitive, we can represent in the exact format. Here it is Y, BCD of Y. Then we have that last part. Here what X and Y are 4 bits, but for P we are going to assign it to 8 bits. So we don't require this to be of 4 bit 0. We can simply assign all 8 bits to P. BCD Y is not declared. Underscore is missing here. Okay. Then we have that BCD underscore P assigned to that output. Okay, fine. So we have all the 3 BCD port mapping added here. Next we have to port map that LCD part. I name it as LCD1 and copy that LCD component name, port map. For this we have that clock will be assigned to clock. Okay, next we will be having that BCD of X will be assigned to, again the signal as well as the input ports are same for LCD, so BCDX only. So BCDY will be assigned with BCDY. Then we have that BCD of P will be assigned to BCD of P. Next we will be having that LCD signals, LCD register select, again the same name, LCD ORS, then LCD enable, LCD of E. Finally we have the data of 8 bit will be assigned to data of 8 bits. Okay, close bracket. So that's it. We have port mapped that binary to BCD and LCD code. Okay. Next we quickly create a constraints. Create. So I name it as binary to LCD. Finish. Just open that editor and paste that XTC file, XTC Spartan 7 XTC. Okay, we required all these clock and switches. Paste it. Then we require that LCD part. This is the LCD part. I'm copying. Okay, fine. We have to rename that port. It should be of X. Okay, then we have that Y port. Then we have a P. So its number should be changed. Y is okay. So we renamed all the input switches. So quickly run this one, generate bit stream, and we can analyze the schematics. Okay, so we have this nice schematics created. You can see that clock as an input, XY or the 4 bits of input, P or the 8 bit input, and you have that LCD, everything port mapped. So you can expand and see how this module was created. You can see that binary to BCD logic here. Same way you have that LCD logic that was implemented. So it looks quite complex because we have so many conditions involved in that LCD code. So it looks very so many logic circuits implemented. Okay. So next we set the hardware and see the output. Okay, hardware was created, so let's turn on the kit, open hardware. Let's do program. You can see that it is displaying x as 0, x hyphen 000, y hyphen 000, then p with 000. If we change that the first 4 switches, x data will be updated. You can see 1, then 1 is of 3, then 111 is of 7, 41 is of 15. So the same way for y, it is updating 3, 7, 15. So 15, 15 are updated on x and y. If I make that p inputs, 8 switches were assigned, I make that p input as all the switches I am enabling. So you can see that 255 is displaying. So 0 to 255 values we can assign through this p. So with this experiment we can modify that LCD inputs in real time. Thank you.